Last one is problem D here. And it says that the grain has a density of 0.8 grams per centimeters cubed, and the density of steel is 0.8 grams per centimeters cubed. Find the weight of the silo when it's full. Okay, so remember that, let's see, it was density, right? Let's look up our density formula here. And that is density equals mass divided by volume. So density, oops, let's try that again. Density equals mass divided by volume. Okay. So if the grain has a density of 0.68 grams per centimeters cubed, and the density of steel is 8 grams per centimeters cubed, find the weight of the silo when it's full. All right. So let's see here. So let's first figure out how much all the grain is going to weigh, because that's what we're looking for, is weight, right? So the grain has a density of 0.68 grams per centimeters cubed, and it had a total volume of 5.2. Well, let's just go with their answer here, 5.2 cubic meters. And we should now be able to figure out what the mass is, right? Because that's over 1, and we just multiply this times this, divided by that, and we get that the mass is going to equal, let's see, it's basically 5.2 times 0.68. You divide that by 1 and you still get the same thing, so 3.5, let's go with 3.54. Right, and that's, I guess, no, it's not grams, certainly not grams, right? So that's going to have to be, that's per centimeter. Let's see, that's going to, okay, we actually need to back up here because this here is in grams per centimeters cubed and we have meters cubed, so we have to convert first. It's just going to make our life easier, so let's do that. So we have 5.2 meters. Let's do this over here. 5.2 meters cubed. So we're going to convert that into centimeters, and it's cubed. We have to move over twice to get to centimeters. But since it's cubed, we have to actually do that 3 different times. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So it's really let's see, 1, 2, 3, 1, 2, 3. It's really 5,200,000 centimeters cubed, and then that's going to give us our mass. Right, so we do this. Sorry, so we got to multiply this by this, and that's going to give us our number of grams for our mass, right? So the mass is going to equal, so let's turn this back on, and it's 0.68 times 5,200,000, which gives us 3,536,000 grams, all right? Which will then just turn into, let's turn that into kilograms. 1, 2, 3 back, so 3,536 kilograms for the total amount of grain, the grain weight. Okay, so we also have to go back and calculate how much weight the all the steel is going to be. So that's so we know that there's 15.7 square meters of steel. So let's use that. So we have 15.7 square meters of steel. And let's see, the steel is 8 grams per centimeters cubed. That's the density of the steel. Okay, we also have to keep in mind with that the steel way back up here at the beginning says it's 3 millimeters thick. So we've got millimeters here and we got meters here, and we ended up with cubic centimeters here. So let's turn everything into centimeters maybe. So let's turn this into, so to go from meters to centimeters, we got to move it over twice, but again it's squared, so we got to do that 2 times. So it's 157,000 square centimeters, right? And then it said that it was, we also had 3 millimeters thick is the steel. So we got to move that into centimeters also, so that's 0.3 centimeters. So we multiply that by 0.3 centimeters to get our total volume of steel that we're using. Okay, so we do 157,000 times 0.3 gives us 47,100 cubic centimeters of steel, right? So that's our total volume, and again we know that the density of that is 8 grams per centimeters cubed. So let's do this. Density equals mass divided by volume. So density equals mass over volume. So in this case the density is 8 equals our mass divided by our volume, which is 47,100 cubic centimeters. And again, thankfully we're already in centimeters cubed here, because this is grams per centimeters cubed here. So we're just going to cross multiply like we did before, and really that's over 1, divide by 1. So we get that the mass is going to be 8 times 47,100. 8 times 47,100 gives us 376,800. And that is going to be grams. So we move that back over 3 spots to get back to kilograms. So mass is 376.8 kilograms, right? So we have those, we have this mass here, and we have this mass here. So this is the grain, this is the silo, so we just got to add those two together. 3536 plus 376.8. I get a total mass, is whatever that is, added together, right? Isn't this fun? This is a long, complicated problem, but man, you figure this out and you've got it all figured out. So 3,536 plus 376.8, and we get 3912.8. So let's just call that 3913. 3913, and this is all kilograms. All right, so that is our total mass for that thing there, and that was one problem. Now, granted, the rest of the problems on here are not going to take that long as well, but anyway, that's how you do that problem number 2. Okay, so now you should be able to say that I can use various formulas and strategies to solve more difficult real-world type problems. Okay, and again, that's definitely the trickiest problem that you're going to run into. Okay, if you have questions, please feel free to ask. Thanks.